Welcome everyone to another DB Services QA Academy class. My name is Laura. I'm a quality assurance engineer for about 12 years, and I will be talking to you today about performance engineering. So what is performance engineering? In summary, we can say that performance engineering is the process of identifying and eliminating performance bottlenecks by exercising different workloads that mimic user patterns. So what does this look like? First, a stimulus or load is introduced to your system. This load simulates a number of different users doing usual tasks, day-to-day tasks. After these tasks are processed, a response is given in the form of various metrics that can be analyzed to help improve the performance. This process is repeated, generating a cycle. First, we design and execute the test scenarios. So this is the test part of the cycle. After, we analyze the results and try to identify the bottlenecks and root causes for these bottlenecks. This is the analyze part of the testing cycle. After we have the report part, that that basically we need to create a document with all the findings and also improvement suggestions. Okay, this is very important for the developers to be able to improve the code or improve the application performance. Okay, and finally, the developers try to implement these suggestions, and the test starts again for us to see if the improvements generated good results. This cycle it's repeated until we fix all the problems that we need to fix or that we can fix. Okay. So what types of performance tests there are? We have several, okay, but these are the most common ones. So the first one is always the baseline, okay? The baseline basically is the system being evaluated under expected or usual conditions. These tests uses normal loads or of an existing system, okay, without extremely high or low numbers, okay? And it's basically used as a base to comparison. Okay, so if you don't have the baseline, basically you don't have anything to compare with because you can compare a performance test executed in a test environment to simply some numbers that you got from production. Okay, so you need to do the baseline to be able to compare apples to apples. Okay, in the same environment with under the same conditions and everything of this. So uh, after we have the stability test that measures the system under sustained load for a long duration. So it's the same thing as the baseline, but is executed for a long time, usually more than 4 hours. Okay, so the goal of this test is to detect leaks in the system that can happen along the time. For example, a memory leak that only occurs after 10 hours of usage. Okay, so this is pretty common. So this test is really important. Okay, after we have the stress test, okay, so basically it measures the system beyond specified limits and using higher loads. Okay, so higher loads than the usual, than a normal day load. Okay, so for example, a Black Friday simulation would have many more users buying stuff online. Okay, so the load will be very heavy. Okay, so this basically is a stress test. So you can base your stress or high load on production data, or you can just apply some percentage of increase. Okay, so this is pretty common. We have also a breakpoint test. There's a type of stress test, and basically you keep pushing and increasing your load until your system breaks. This also is very common and has the goal to see how far does your system can handle the load. Okay. We also have a spike test that measures the system under stream load with no warning. So basically, there's no ramp up, there's no easy into it. Okay, so in the stress, you start with low users, low amount of users, and you keep increasing um, slowly, slowly increasing usually the load. And the spike, you just put a high load with no warning, uh, and it dump it in the system, okay, for a short period of or time. And the goal is to evaluate how the system recovers and if the system can recover from that. Okay. So, having said the types of tests, what are the pre-requirements for an effective test? Okay, so this is very important. Uh, Basically, you need an accurate and detailed test requirement. So for that, uh, good definition of ready document is vital. Okay, so you need to have your testing goals because depending on the goals of your test, it will change completely the dynamic and the scenarios that you will be executing. We need to know the SLAs if there are any, what changes did happen in the application, if any. Okay, you need to understand all the architecture. So how does the system connect? How the if is an ecosystem, usually is. How does any part connect to each other, and by which technologies, and what database is connected to, and all of that architecture details. Okay, you need also to have a stable infrastructure, so that means a dedicated environment. Mm, a lot of a lot of companies don't give the, I think, the needed importance for that part, but it's really important to have a dedicated environment for performance testing. Because if you are using the same environment for another types of testing, and for example, you are executing a long run for 12 hours, and during your run, some other colleague goes in the environment and executes a heavy job, this will basically ruin all of your results. That's one reason, okay, but there are many others. For example, you need to have to be able to calculate a percentage of production, okay, a scalable percentage. For example, if you have uh, four nodes in production, four servers in production, it's good to have at least, for example, two in the performance environment. So you can say that your environment is 50% of production. So you can apply this 50% on your final numbers, result numbers. And this way, you know that your results uh, are proportional, to production. And this is vital for your results to be accurate, you know. And also, you need to have the right tools to perform your job. So let's talk a bit about performance metrics and tools. Okay, we have a lot of metrics, different metrics, but those are the most common ones. So for the system metrics, remembering we always need to look at the architecture as a whole in the performance testing. Okay, so at the same way, we need to take a look at various different parts. Okay, so first of all, the system metrics, we have the CPU usage, the memory usage, the disk network also usage, and we need to collect that for each node of your architecture. Okay, this is really important because sometimes in one node there's a number and in the other node is a different number, and with that you can see if there's being a load balance is being done correctly or many other problems that can be happening. Okay, also you have the transaction metrics that basically are the response times, the throughput that is message or hits bytes per second, usually per second, but can be different time. And these metrics of transaction usually are collected by the load generator itself, or the tool that you're using to generate your test, to run your test. Okay. There are also the database metrics. For example, the SQL explain plan, the cache usage, the how many compilations are being executed per second, how many table scans, either scans, number of sessions open. Okay, the plans are the most important ones. Usually use it. Okay, to see the indexes and all the stuff. We also have the application server metrics, that we can see the concurrent amount of concurrent users, the CPU memory usage by process, and the number of threads. Okay, those are just some examples. So what are the common tools that we use for performance? Okay, so the performance tools per se, we can use, there are a lot of usage of JMeter in the market, because JMeter is a open source tool. Okay, so it's a very good one. We have Blaze Meter, that is another version of JMeter, a paid one with a lot of other functionalities that usually we need depending on how big our test is. We have Load Runner, that is a paid, very common used also tool, and we have New Load, that is another very used tool. Okay, paid as well. For the monitoring part, we can use, if your server is Windows, okay, has Windows, we can use Windows Performance Monitor, the WMI. For the application side, we can use Riverbed, Splunk, that basically you can see all the metrics from the logs and also the server side, okay, and the application side, of course. And for the beam monitoring, database monitoring, if it's Oracle, we have the Oracle's OEM, the Oracle Enterprise Manager. We also have SQL, Microsoft Management Studio for for SQL databases. But usually the performance tools collect internally the majority of the metrics. Okay, but it's good to have to see and use external tools to be able to get more detailed metrics as well. Okay. And this is a very crucial part. So how to analyze the results, okay? The performance results are not obvious. And if you see a bunch of numbers, a mountain of numbers in front of you, that if you don't know how to read them, basically is useless. So the analysis will define how much the results will be useful, okay? Because the interpretation you give for those numbers are the real meaning of the results, okay? So experience is key. It's very rare to find someone who is really expert in performance testing, because it's not a lot, it's not done a lot in the companies. Okay, so it's this experience. Every test you do brings new knowledge, and it's a continuous learning. And this, because systems are always changing, technologies are changing, architectures change. So it's really important to keep doing it, and keep analyzing what happened each time. Okay, for you to learn. So correlation is a method really commonly used, that compares the results to determine their dependencies. So impact analysis, for analysis, doing questions. For example, what is the throughput impact in the CPU? How the load impacts the memory usage? Which resources or processes use more memory in CPU? How is the garbage collector behaving during the load? What are the top queries? How can we fix them? Is their plan good enough? Is there any missing indexes? During a long run of 12 hours, how does the application memory behave? There were any leakages? During a test execution, for example, if you increase the load by 50% and then reduce it back to zero, how did my system recover? Did it recover? Was there any locked resources in the results? So there are many questions that you can do to help you analyze and give meaning to the numbers. Okay. So let's see a simple example using JMeter. Okay. Test. This is a test that I created on JMeter, and basically uh, it's accessing google.com and starts with 0 user and is increasing 1 user per second until it reaches 100 users. Okay, and each user will be executing 10 iterations. So there's a simple small test just for us to see how many different interpretations we can have with this. Okay, so basically, you can see here the metrics being created inside Load Runner. Okay, so this is a metric. All of these numbers and this chart basically is inside the JMedia. Okay, so the green one is the throughput. So it shows the how many hits per minute. In this case, it's minute. Okay, so this number, the higher the better. So if you can reach, if you don't put any limits, okay, and if you higher than you are able to get this number, the best for your application. So basically, it means your application can handle really high loads. Okay, the deviation basically measures how widely the points in a data set swing back and forth from the mean. This is the red line there. So basically, it shows how stable is your system. So if this number is really little, it shows that's little volatility. So it's your system is more stable. So less the better in this case. For the blue line, we see the arithmetic average. So this is basically the simple average we can see. Okay, and it's useful if you have a pretty stable um, system. Okay, with little volatility and small occurrences of discrepant values. Okay, because if you have a lot of different values in your test, this average will trick you. Okay, so it's not a good number to use if your system has a lot of volatility. Okay, that usually is the case. A median is better because median separates the upper half of our number set. Okay, so it shows the central tendency of a skewed numeric distribution. So it eliminates the discrepancies. Okay, so it's very good. We also have some other examples like 90% average that eliminates 5% of the top discrepancies and 5% of the low discrepancies. This is a also good number to use. Okay, good metric to use. Um, so let's see what are the results here compared to the Yahoo tests. Okay, so basically here we are seeing Google results and Yahoo results. That's the same tests as the Google, but reaching Yahoo site. Okay, so in this test we can see that the throughput of Yahoo server it's 867 per minute. Compared to Google, Yahoo doesn't have the capacity to process the hits as quickly because we can see in the Google test we reach more than 1,400 hits. Okay, so Google process hits faster. Okay, for in the deviation, what answers does it give us? Okay, so Google's deviation was 577 in comparison to Yahoo. There's 2,000 more than 2000, 2689. Google proves that is way more stable, okay, because the number is really, really, really less, really smaller, okay. And for the average and median, we also can see the same thing. We can see that the Google is more stable because in the average of Google, we have 967. In the median, 987. And in the median, we have 961. So it's only 20 the difference. So it's very, very stable, okay? And if you analyze the average and the median from the Yahoo, we can see more than 1,000 of difference, okay? So you can see that in the plain average, we have a lot of discrepancies, okay? And even so, with without taking this difference in consideration, we can see that the average and the median response times for Yahoo are really, really larger than the Google one. So basically, we can see that Google is way better in performance than Yahoo with this simple test. Okay, so this is pretty simple, but it already gives us a lot of information. Okay, so that was it. It was really quick and really summarize it, but the goal was to give you an introduction on performance testing and to you see how important it is and how complex it is. Okay, and there's a lot of things you need to take in consideration, and maybe in the future we can give you a more detailed class about this. Okay, so thank you for watching. I hope you enjoy it, and bye bye.